Hello everyone. Mike, am I audible? Right? Okay, thank you. Good afternoon everyone. Dominic, um, I'm working for a company called Suse, mispronounced many times I heard, but that is supposed to be Suse. Suse is a Linux operating system company, um, not just famous for Linux operating system, but not that limited to that one. We do operate on the container space as well. Okay. So today I was asked to provide some insights about Kubernetes, plus how to make Kubernetes so easy for everyone. Because we have seen in the previous session, thanks to Ansel for providing us the insights about how hard Kubernetes and how to make it easy, thanks to that. But we are going to see some of the um, or probably most of the KISS elements what you have just answered. It looks like everyone is comfortable with the topics that we discussed or what was there on the KISS. But anyway, I'll give you a refresher, okay? So the agenda that I set for today is this one. I'm not going to go through every element because of time constraints. So what is containers? How many of you guys are working on container space? Can I get some insights, please? Okay, thank you. And so that means could be, I mean, this is probably boring for you guys if you know, because today I'm going to cover the basics. Um, so for those who are not from the container background, we have seen Ansel has shown us how to um, uh, how to install a Helm chart application, how to build a container, sorry, how to build a Kubernetes cluster. But you must have also answered something about pod, right? What is pod? And what is pod it is? We asked for that. I'm coming to that area. So traditionally, probably I think it's worth to start with what is, how did that begin? Um, let's say for example that we heard monolithic application structure and microservices. What is monolithic? It's just the way that we have or we are all studied in our colleges, right? We build in our labs that we used to build, you know, the front interface, database, everything is in one program. When it comes to if you visualize that to the enterprise level, then that is a very lengthy program with a lot of functions. Everything is then. So it's very hard to maintain and in the long run, or it's a kind of a very rigid format, not easy to modify or not flexible in a way that what business really want, they cannot modify it. Having said that, thought about how to segregate or how to split or how to make this program easy. So this is an architecture concept called microservice. That microservice is nothing but every component, those are independent or independent to each other that we can separate from the bigger program. Let's say for example, Amazon. Just take that as an example, amazon.in or com, where you see that you'll have a session for home appliances, books. Those are independent from each other. And of course, the payment session as well. That is completely different because you don't need the payment while you are browsing or selecting the product, right? So it is completely different that once you have finalized the items that you are planning to purchase, then you go to the payment time, right? So then those are slightly that if you visualize, those are independent and that we can separate from each other. And what is the benefit on Black Friday or whatever, White Friday, whatever the days comes in, I can so easily scale one of the functions because I am expecting more traffic is coming on the day, then I can easily scale that particular component to multiple virtual machines or multiple functions, rather than in a traditional way. What we used to do is that we have to build a lot of virtual machines and deploy that or scale it in a way just because of for the day. But with the microservice architecture, with the container, thanks to containers, we can actually scale in a very easy way, and we can scale up and down in a fraction of seconds. Okay, so that's how a very high level idea of what is microservice architecture and monolithic architecture. So we are talking about microservice architecture. Now, coming back to what is container images. So, like I said, we do have applications. That is, we know that, okay, let's say for example, the same function that I have talked about, payment. So I have decided, okay, these are the payment terms, or the settings that I wanted to accept Visa, MasterCard, all of those. I have packaged everything, those applications to handle. That is a static component, which is something along with the dependency needed for my program to run. In this, if I go with this example, I have a Go program which has got some dependencies are there. Everything that I have packaged together and made it as a a bundle, like the same way that I give you a gift, everything is there. You have everything is in within that. You just need to reuse it whenever you want to use it. So that's the purpose of container. So I packaged all my application, everything, including that dependency, and I hand it over to the team. Okay, you can use it. Today, I decided to use it for my test infrastructure. Assume you have multiple landscapes. Then from the test, I am moving to the development, sorry, development, test, and then the production or pre-production. So every landscape will have the same impact because the application, the dependency, everything is there. You know very well, even if you are using Linux, the kernel might be different. Let's say for example, you are using Suse Linux or Fedora, let's say Fedora 32. So Fedora 32 will have a lot of kernel, um, different kernels are released, right? Even though we are saying it's a Fedora 32, but each one, there's no guarantee that everyone will be running the same set of package level, the same set of kernels, right? So that can create, in a big enterprises, that can create a lot of conflict or application dependency issues when they are in real production. So we need to guarantee that the dependency are there with the application, so that doesn't break, that is completely independent from the underlying hardware or the dependency, so that it will run smoothly on every landscape with no surprise. Okay? So that was the reason why the container images are, or it has got a more, um, it was appealing to everyone. So in a container images, for those who are not from this background, um, this is a very high level basic structure of a container images. So Ansel has, in the previous session, he has mentioned about namespaces. So namespace was a concept, was there in the Linux itself, but there were no real uh, implementation of that. So that has made by Docker. Thanks to Docker for that. So everyone has charted into that. And this was one of the way how a Docker image or Docker file will look like. So definitely we need a base for the Docker file to build. The structure says that, okay, I'm going to have a base of a Ubuntu based image, which has got a label, just to identify who is the maintainer, all of this. And then I have to do certain set of actions inside the container, and then copy some files, could be my applications, and then execute a command or make it as a work directory. I mean, this is with respect to running an Apache web server, okay? So this is, everything is pre-written. Now it is packaged. So how do we package that? And then, sorry, this is PowerPoint tricks. Okay, just to have an idea about what it is. Now, once you have everything is ready, and then you have to build that image. We use typically that we use the Docker command, Docker build, and then you build an image. Of course, every program has got an input, and you will get an output. What is the output? Output is an image. So once you build this, you get an output, which is nothing but an image. Okay. So the image that you can use it for many places. Image, remember the word image. I'm talking about image. And then a running instance of an image is called as a container. Okay? So once it is in action, that becomes, or we call it as a container. You must have seen this in the previous session. Probably I'll walk you through very quick and then skip. Okay? This is nothing but talking about in a traditional way that we have hypervisors, where you will have a physical abstraction, physical isolation between multiple applications, which is usually what was there in a virtual machine. So what is it found very often that the resources are really dedicated for virtual machine as well as for the application. So there is we shouldn't limit our visualizing power up to just to this level. We have to think wide. In a large enterprise where you have thousands of virtual machines just to hold this, then think about the resources are allocated just for running virtual machines. That is huge, massive, okay? And the software needed for that, of course, every virtual machine required an operating system. The subscription cost for that is huge, right? So having said that, when it comes to the microservice model, where you have a small footprint of an OS, which has got which is really depending on the working on top of something called container runtime. Here in this picture, that is a Docker. There's no hypervisor is in place. So that's how that we run a container, okay? Of course, I have built an image. So if you come with me the path that we build an image as of now, right? And we have got an image, which is something that's my application. I wanted to store it somewhere. How do I keep that? I cannot just keep it in my pocket, right? Or store just in one of my machines, okay? So we need a place where I can safely and securely store the image. Remember, safely and securely, that what I mean is that it's not, doesn't mean that, okay, someone will steal that image, okay? It's also possible. It's also possible, but I mean that from a security angle, cyber security angle, we need to ensure that the dependencies that I added are free from vulnerabilities. Okay, so a lot of features or a lot of things that we need to consider rather than just storing an image. Okay, so we need or the place where we store such images are called container registries. So there are so many free registries are there, paid registries are there, feature-rich registries are there. Docker Hub is something very common, which is a public registry. Also, you can host it something on your laptop if you really wanted to have a small replica of that. Okay, not replica, but similar that something sort of thing. Okay, you can build on your laptop as well. So this is how it is. So the working in traditional way, the working model is that you build the image, you push the image to the container registry, then you pull it whenever you want. Then you run it in your production or whatever the landscape where you are planning to deploy it. Okay? So any questions until this point? Okay, silence could be you didn't understand anything or you understood everything. So I take it as in a positive note. I believe everyone got it. Okay, good. So I was talking about one container that we were building one application. right? Now, imagine I have got a thousands, you know, I don't have it. But just assume thousands of applications are there. But it is quite possible because let's say assume that I have 10 applications available as of now. Just 10, assume. I have made some improvement on my application, and then I don't just modify that just one of the 10 containers. No, I will build a new container that will add, let's say for example, my application, my app version 1, I wanted to improve something, then I rebuild the image and then publish a new one. So I have got a new container image called my app version 1.1. Okay, so it's not I'm replacing the older one, but in production or whenever I'm in use, I will point out, okay, which version of the container that I want to use it. But all of them would be there. Again, if you think big, there will be multiple container registries would be there. Only the final product would be go to the primary registry. The rest of them would be on a different registry. That's also possible. Okay. Now, when you have more containers, you need an orchestrator. That orchestrator is nothing but Kubernetes. Of course, in Kubernetes, we have heard enough. Kubernetes is open source container management platform, and that works in a declarative way. That means we tell them that what you wanted to achieve it, not how to want it. Then everything in Kubernetes is treated as a resources, and then you can create, retrieve, update, and delete multiple resources. Okay. High-level architecture of a Kubernetes, just to imagine, we widely call it as a, master nodes and worker nodes. Those are the two roles are available or there in the Kubernetes. Sometimes it is called as a control plane and data plane. Control plane is nothing but who is the brain of a Kubernetes, and the etcd is the key value data store to store the state of the cluster. And then there's a worker nodes, real hard workers. Okay, so where the application is running. Then definitely there is some standard format. Otherwise, everyone will come up with their own way of definition, right? So there's a standard way of, or we interact with the Kubernetes in a YAML format, or that's so easy. We can have, or typically there are, the structure of a YAML file will have 4 sessions. One is a API, kind, metadata, and spec. API version, nothing but it's talking about, which, what API feature on a Kubernetes that we are trying to use it. And kind is what kind of a resource that, or we are planning to, object we are planning to create it. Metadata is about data, and then spec is about what the details of a container or the thing that we are planning to create it at a very high level, okay? So few of the main Kubernetes objects, I'm not going to cover all of this, but just for your, again, for your imagination, okay? Pod, deployments, services, ingress, config manage, secrets are few of them. And we are going to touch base the pod, which is the smallest unit in a Kubernetes. So image credits from the Kubernetes IO. If you go there, you will find it out there. So once I have, so if you are with me in the journey, you'll imagine now that we have got an image ready, right? We build a container image. That image, I want to make it in action, okay? Then how do I do that? That for which I have to take that image from directly from my container registry, then run it inside Kubernetes. Of course, Kubernetes has its own policy that how do I execute my container? That means, let's say, yeah, here I was told to use this mic, okay? The same way, in Kubernetes, it was told to use when you wanted to run a container, you have to run inside a pod. Okay, so the smallest unit in a Kubernetes is called pods. Okay, you can combine multiple containers together or one container, up to you. But again, just to give you again some highlight about if you have an application depending on some other function, then you can combine those two containers together and group it together and run it. Because when you are scaling up, then you need both the application to be scaled to to meet the requirement, right? So then you have to do that. This is just a YAML example for you to again look at it. This is how we derive or define how to run a pod. The name of the pod, what image. Here I mentioned the image. Here I can mention the version of the image as well. Okay, and then what port it connects to that, and the metadata, the labels, all of this are talking about what type of container that I'm going to run it. So the challenge with the pod is that if you have got one pod, it has got its own IP address assigned. Okay, assume that it has crashed somehow. Okay, somehow it crashed, maybe due to not because of the program, maybe due to the resource limit, maybe not enough memory there to run. Then there's a possibility to a crash. So um, there's no way that we will get to know unless we specifically look at and do that. And there is another smart way of doing or managing an application is a deployment. So with this, probably I can show you something on the in action, then you will understand that. But I'll switch to that action point at the later point, but please remember this, don't forget this, okay? So here, deployment will help you to manage multiple, to ensure that you get a container at a desired state what you are expecting. Let's say, for example, just for now, you wanted to have 3 copies of one application, okay? And one of them crashed. Deployment will ensure that you always have 3 copies of the same applications, okay? So that will keep in track of that, and also that we can use it for updating your application, scaling, rollback, all of this, it's possible, okay? So this is one example in a PowerPoint way of visualization, okay? So this is saying that, okay, this is a type of deployment type. I'm going to install, I need an Nginx application container. This is a version of the application. And then I need 3 copies of that, okay? 3 copies are there. And assume something happened to this and one of them crashed or dead, or the node is down. And immediately the Kubernetes will, or the API will get to know that, oh, okay, so this is something, is not what I am expecting. I supposed to have 3 nodes. What should I do? I should maintain the desired state and actual state should be same. So then that will bring up a new container, will spin a new one, okay? That will ensure that the current state and the desired state is same. Okay, fine. So as of now, we are inside the Kubernetes. We just run the application, fine. How do you consume that application? If you are with me on the journey, again, build the application, we push to the container registry, pull the application, we run one pod, and then we decided to scale in a massive way. Then we decided to go to the deployment. Now, everything is fine, but how do I consume this application? Then you need something called as a service, okay? When you have got if you remember, every pod has got its own application, IP address, and when a restart happens for a pod, that will, or when you spin up a new pod, there will be new IP address assigned for each pod. So you never, it's quite impossible for you to keep track of every IP address and know that which pod is running my application, right? So instead, we will create one more layer between or just above the deployment, which is called service. So the service IP would be remain same, static kind of an nature, and everything under below that would be in dynamic in nature. So you just need to interact with the service IP, not with the, the level below. So again, this is a PowerPoint level of visualization. So there are multiple type of the service types are there. So something happened to this pod. So look at this. The IP address was zero 0.6. This has crashed, and of course, Kubernetes is good to know that. Oh, it's not matching with my desired state. So I need to recreate new one which has got a new IP address. If you are individually tracking each ports, then it's very, very difficult to keep track of the IP. We don't know what IP will be assigned to the port. But now with the service, since we are interacting with the service only, that we can easily, or it doesn't impact in our operation. We can just, access the service type. So like I said, this is the cluster, and there are cluster IP type of a service is there. That means that is accessible within the cluster. You are interacting with another application within the cluster due to many reasons. One, security. You don't want to expose this to the outside world. The second, it's easy that you can, probably the function, you really by the function of or the purpose of the container, you don't need to expose it. Maybe finance container, which is owned by them. Some sensitive data is there, or is no need to be exposed to the outside. Okay, then you don't need to. So in that case, you can use a cluster IP. And then another type is called node port. Node port is when you wanted to expose to outside world. Here, again, this is a node. We are consuming one of the free ports available on the node to expose that. Of course, you need not just IP, you need a listening port to connect to that application. Okay, so that is going to be, in this case, node port type is required. And the other one is load balancer. So the load balancer is when you wanted to connect to your, or expose to the public. That means none of your host details are exposed. Public will connect to the load balancer IP, and then that will reroute the traffic to the node. Okay, so that's how that connectivity works in. So there are three types: node port, cluster IP, and load balancer. Load balancer typically that is used for in a public cloud area. Okay, here's a sample of a service file. Now, very quick, I don't want to go in deep of an ingress. This is again another type of a resource, which is mainly typically used for HTTP connectivity. And here, again, you get when it comes to load balancer, probably I think I'll use this one, will give you some idea. So the ingress will be between the services or one level above the service. Okay, so the ingress managed load balancer will be contacting the ingress within the controller. So what happens is that, assume that I have got 3 services, okay, or more than one services are there. I should have multiple load balancers to connect to each service. That is going to cost a lot. Again, it's not about the technology, it's doable, but also think about in a bigger picture, that is a cost also involved there. So that means I have to deploy more load balancers to connect to multiple services. More load balancers means it is a cost if I'm running in cloud. Okay, so how do I overcome this in a technical way, tactically? So that's how this is the ingress comes in picture. So I'm going to use one ingress there. going to be my mediator for between my public load balancer and my service. What happens next is that this will give you more picture, I think. So I'm going to have, see, this is the same URL. Look at the URL, the website address that I'm going to use. It's a foobar.com, foo.bar.com, and then slash. After that, that path is different. In my application, I will reroute to different path, but I'll use one load balancer to reach out multiple services. Okay, so the service definition talks about where do I look at? If I am accessing foobar.com/foo, then connect to my service A at port 4200. If it is /bar, then connect to service B at 8080. So with one load balancer that we are separating the traffic. Okay, so it's again a benefit. Now, secrets, config maps, secrets are nothing but the passwords, and config maps are when you wanted to have some environment variables or some static or dynamic, sorry, those variables that you wanted to pass it. Okay, so those are the config maps. So here is the just a high level of how config maps looks like. Now it comes in towards the action time. So if you remember what we have covered as of now is that we build an image, push to the registry, pulled it for your production purpose, which is inside the Kubernetes. We run it inside the pod. Then we go to know that pod is not sufficient to meet my purpose. So I need to go for a much more flexible way of managing pod. Then I decided to go for a deployment so that I can scale out, scale down, then I can upgrade easily. Okay, and that will maintain or will ensure that the current state and the desired states are same always. Then how do I access my application to the outside world, for which I have used services object. That service, within that service there are three types are there. One was a cluster IP, which was for to use inside the cluster. The other one was a load balancer, which is something that I wanted to expose to the public. The other one was the third one was a node port, in which my host port is going to be used, which is probably good for your internal purpose, not for exposing to the outside world. Okay, so we are up to this point. Then we have seen ingress, and then how do we ingress will solve the the requirement of having multiple load balancers. So we have eliminated that point and used ingress to reroute the traffic to different containers based on the access pattern. Okay. Now, we have seen Kubernetes deployment in the previous session. You have, since we wanted to configure a different namespace, the CNI, we have used or updated some modified the configuration file. But otherwise, it is very difficult. You can imagine that you will have a container upstream if you are using. You have to build and plug each component together. Then you form a cluster, or then you form a Kubernetes. And then if you want have a cluster, that means connect to group of machines, then you need a network which is called CNI. Cilium was the one in the previous session that you have seen. There are multiples. So now you can imagine how difficult it is for a Kubernetes to build a Kubernetes from, not to scare you, but that's a reality, which is mean for a purpose that you can easily plug and play with the component based on your requirement. It's not to complicate things, okay? But at the same time, we do have, like you said, you don't compile your Linux your own, the hard way, right? Rather, you use a distribution. So again, this is something that there are a couple of famous distributions are there. One is RKE. It is nothing but Rancher Kubernetes engine. The other one is a Rancher Kubernetes engine version 2, RKE2, which was originally developed for US Federal. So that means it has got all security elements are passed. And there's another lightweight Kubernetes called K3S. I don't know whether you heard about that. That is for edge use cases. That means if you wanted to run a Kubernetes inside a Raspberry Pi kind of a device, it's possible. That means you need a small resource hungry element should be there, right? It shouldn't ask for more resources. So then you can consider K3S. That is suitable for your workstation as well. Okay. Now, when you have, we have seen Kubernetes, when you have multiple images, then you need an orchestrator. Now we are going to the next level, which is when you have multiple clusters. Okay. Then you need another orchestrator, which is called multi-cluster management tool. Rancher is one of them. There are many. Rancher is one of them, which is from on by Suse. Okay. I'm not going in detail of this, but rather I wanted to show you a demo of that. Before that, just again, this is a couple of use cases that you must, or again for you, you can visualize it. So Rancher would be, the high level architecture would be something like this. So you will have a Rancher management server deployed on 3-node Kubernetes. Of course, now you know why we are talking about odd numbers, right? Because it's said that the algorithm that needed the odd numbers to maintain the high availability. Okay, so there are 3 nodes available in which where I'm deploying my Rancher, and then everything below, the one level below is called as a downstream clusters. Okay, so there are multiple clusters are there. Now you can see there are control planes, there are 3 control planes. Worker nodes could be the real workers, could be any numbers. No need to be odd number or even number, I mean anything could be. But the master should be odd numbers. 3, 5, 7, that should be the way. So you can, from a central console, you can deploy multiple Kubernetes clusters. This is one way of meeting a business requirement or what you are thinking, you wanted to serve it. The other way is that we wanted to slice it one cluster for multiple customers. Imagine that you are working in an organization where you have multiple departments are there. Rather than spinning a new cluster for each department, because maybe due to the team, they have got just one application. They don't need a massive cluster for that. You don't need to do that. In that case, you can slice your cluster into multiple and grant that to the team, those who are relevant, and you can expose that to only those pieces to the team. Now you can imagine if it is in a virtual machine scenario, you have to create multiple virtual machines when they are in need. But in Kubernetes, based on the demand, you just need to scale that application. That's it. And scale down, very easy. Okay. Now switching back to, I wanted to show you some, how Rancher is look like. Is it visible or should I? Better? Yeah? Okay. Good. But since I zoomed in, it's going to give you some alignment issues. Probably you'll see rather than a single line, 2 lines, okay? Bear with me. So now, I have got one cluster which is called local cluster. That means the cluster where, if you imagine the previous picture, where my Rancher management is deployed. And I have got something called production cluster, which is again running on EC2 instance. All of them are, and using this version, and this is the resources that I wanted to, I have assigned for. With Rancher, you can easily create a cluster. Okay, so you can create it on, because there are EKS, AKS, GKE, there are, the Kubernetes are there provided by the cloud providers. Either you can use that and spin a new cluster, or you can create your own, using RKE1, see here, RKE1, RKE2, RK3 as kind of a distribution, and you can use it. It's easy to plug with your VMware infrastructure in case if you're using. Then the steps to create a cluster, now you can see that, how a cluster, a multi-cluster management tool will ease our life, okay, building a cluster. So now, of course, we have to give a cluster name. I'm going to give it as a dev, and this is asking for, number of nodes needed for that, the name prefix. Let's say that master, every master nodes needs to be prefixed with the master. Number of nodes required is this. And then I have to, so here is a template is there. I'm selecting this template. This template is talking about which, what resource are assigned to that, like a number of CPU, disk space, all of this are, okay? And then assign the role, etcd, control plane, and I think this is a worker one, okay? Okay, so worker is needed. I will add one more pool, which is for a worker, and then I can decide, okay, so this is two worker nodes are fine. I'll use the same template. That means the same thing. So now I have got um, 3 nodes for my master and 2 nodes for my worker. Okay. What is next? I have to select the Kubernetes version that I want to use it. I'll go for this. Okay. Then if you really wanted to change the network plugin, we have seen Cilium earlier, right? If you wanted to change, then you can change it. And then click create. This will create a Kubernetes cluster at your target infrastructure. That's it. So rather than deploying or doing everything from hands-on with a scratch, this will automate a complete, whatever we have seen as of now, everything will be deployed on a target infrastructure. And once you have a cluster like this is available, once this is built, this will report back as an active. Then you can go inside the cluster like this, explore. Okay, so here you can, how do you want to deploy a new application? If you remember the previous session, Helm chart, Helm is a way that you distribute your application. So there are so many Helm chart or marketplaces there. Probably you are very familiar with Grafana, Prometheus thing, right? Which is for monitoring. So how do you install? So I click on the chart, which is my application. Imagine in your case, if you're building your own application, then that will look like a chart like this. And then you click and then apply all the changes and then click next. This will deploy on the target infrastructure. So easy. So you don't need to again, so the developer will do any modification on this application. They will update the application, push the changes to the Git, and there the Helm chart, you make the Helm chart out of that, and then that will be published on this. That will be easy. Okay, from here then you can deploy the application on the target infrastructure. So let's say for example here, I click install. Meanwhile, while it is, okay, so it is here. Sorry, that is because of my internet connection. So I'm going to install. That's it. So this will install, deploy a new application for monitoring to monitor the cluster. Meanwhile, you'll also get the status of the deployment that is happening on the on screen, rather than you go inside the Kubernetes and looking at. You can actually see everything here. In case if you wanted to go there, or you wanted to access it, you can access the cluster directly from here, and from here you can execute all the kubectl commands. Okay, so that means again, that is in case something is wrong that you would like to look at in deep for the troubleshooting purpose, then you can access the console directly from here. Okay. This is just the ports, all of those things that we have talked as of now is here. Okay. Let me just, I know it's a bit late, but let me just show you one step here. Here, this is an application, my app, like I said earlier, my app, I decide that, okay, 3 nodes are needed. Sorry, 3 copies are needed. And then what image you need, I'm saying that Nginx, the latest version of Nginx I needed. And pull policy, that means whether you wanted to pull it always from the registry where I kept my application. So I'm saying that if the image is, for the sake of time, I'm saying that it is there on the machine, then don't pull it, use the current one. Okay. And then I can create a service from here. If I want, I'm not going to create one. Then I click create. What will happen next is that this will spin 3 ports. It is creating 3 ports will be ready, and that is your application. Okay, so it is active now. And if I go there, and 3 applications are here, right? So I delete, and then look at the IP address. That is a 4.10. That I'm the first one. I'm deleting it. 4.10. It is deleting. So it has created another one, 5.10 or 4.11, right? Immediately. So anything happens to that, so Kubernetes will ensure that the current state, the desired state, is matching with the current state. So this is how, in action, whatever we have seen, the deployment and port, IP address, everything that I mentioned. Okay? Good. Thank you. I think that's it. Good enough. I'm sorry for keeping you guys wait. Questions time.
Are there any questions for Dominic?